Determine points, if any, at which the function has a horizontal tangent line. So your function that you're given is y equals x to the third power plus x. Now remember that the function has a horizontal tangent line when the slope is equal to 0. And in order to find the slope, you have to find the first derivative. So let's go ahead and find that in respect to x. The derivative of y in respect to x is as follows. Find the derivative with respect to x of each individual term. Because there's a sum, you're going to find the sum of the derivatives to find the derivative of the entire function. So when you find the derivative of x to the third, you use the power rule. And whenever you need to find a derivative of x, it's really x to the first power, and that's an exponent, meaning you need to use the power rule here as well. So derivative of y, right? Go ahead and recall the power rule. Towards your right, the power rule is as follows. The derivative with respect to x of x to n power equals n, that power, times x to the n minus 1 power. So it'll be derivative of x to the third is 3, x to the 3 minus 1, plus derivative of x to the first power is going to be 1 times x to the 1 minus 1. All I'm doing is doing power rule, where here n equals 3 and here n equals 1. So the derivative in respect to x of y, or y prime, is equal to 3x, 3 minus 1 is 2, plus 1x to 1 minus 1, which is x to the x to the 0 power, 1 minus 1 is 0, and the derivative in respect to x of y prime is equal to 3x squared plus, where we have x to the 0 power is going to be 1. Now, remember what I said before, whenever we're trying to find the horizontal tangent line, go ahead and make sure that the slope is equal to 0. So you have your first derivative, and we have to make sure that our y prime equals 0, first derivative. So 3x squared plus 1 equals 0. What you're going to do on both sides is subtract 1. You'll get negative 1 equals 3x squared. Now, that is not possible. See, look, watch. Divide by 3 on both sides. You're going to get x squared equals negative 1/3. Any squared term cannot be a negative number. So I'm going to write therefore there cannot exist a horizontal tangent line with real number roots. And the reason why I say that is because if you have x squared equal to 1/3, that's possible. But if it's x squared equal to a negative number, the roots will have to be imaginary. And right now, we're solving for real roots, and so that way we can have real points where they are existing. So right here, they do not exist, and therefore there are no points. Okay.